Okay, the learning target is I can integrate using substitution. And I'm so glad that you guys are worried about your calculus. For example, we have learned all sorts of integration. But what if I'm giving something like this? It is indefinite, right? But how am I going to integrate this? I'll tell you what, why don't you just go on out and not disrupt. You're not interested in the notes anyway. That way he won't be off task 2. Will that work? You know, it is a chain rule. Very good. So how do we undo a chain rule? That's where the question comes in. Well, to undo a chain rule, we use substitution. Okay? That's what we're going to do here. We are going to undo a chain rule. So let's do it. There is the integral that we were given a second ago. I need to use substitution. I'm going to use the letter U. Your AP test will use the letter U, but you could use any variable you wanted. And I'm going to try to find a U that I can substitute in that makes this whole thing a little easier to deal with. I will warn you, usually the inside will work, but not always. The biggest problem with U substitution is actually deciding what to use as U. And frequently you will pick a U and it won't work. So you have to pick a different U, especially where trig functions come into play. However, a good rule of thumb is to try the block if you have one. Try the inside function if you have one. I do have an inside function. So I am going to let U equal 1 plus x squared. I'm going to take the derivative of U. So therefore du equals 2x dx. Instead of saying du dx equals 2x, I'm putting the du on one side and the dx on the other side because I actually am going to substitute two things. I'm going to substitute inside and I'm going to substitute that. So I technically want my du and dx on different sides of the equal sign. Well, I've let u equal 1 plus x squared. I'm saying that the derivative of u is du equal to the derivative of 1 plus x squared is 2x dx. But I need this to say dx all by itself. So I divide both sides by 2x. And I have that du over 2x equals dx. Now I'm going to substitute some things. An integral of 2x times the square root of u. And instead of dx, du over 2x. What does that do for me? That's exactly what that does for me. It allows me to cancel my 2x's. So now I can integrate the square root of u du. And I know that that's equal to u to the 1/2 du. Okay, so that'll be a u. I add 1 to 1/2, and I have 3/2. And I divide by the 1/2, or I multiply by the reciprocal. Excuse me, the 3/2, not the 1/2. Okay, multiply by the reciprocal plus c, because it's indefinite. This year.
You can use as to why there's an integral without an integral.
Remember, indefinite integrals don't have an interval.
I thought it was like,
Because an indefinite integral is a function.
what is that, 3 over 2 something?
I'm undoing the power rule, so I add 1 to my exponent.
Oh, we're doing exponent.
Antiderivative right there. Okay. Now, I'm not quite finished, but I'm really, really, really close. And to the easy part, all I have to do now is substitute back in for u. So, my original integral is equal to 2/3 1 plus x squared, quantity of, raised to the 3/2 plus c. Yes, I guess I lifted my pen.
Is that like the final answer?
That is the final answer. Okay, because we're using u substitution to take an integral, an indefinite integral. So let's try it again with a different problem this time. Talk to me.
I was going to ask if you could explain the steps.
Yep. I will explain the steps as we work through it on this one. How's that go? How does that work for you?
That would be wonderful.
Okay. All right, let's look at another one. We have the integral of x cubed times the cosine of x to the 4th plus 2 dx. The cosine is, technically it's an outside. Okay, technically it's an outside. Remember, using the inside doesn't always work. Okay, and I'm not going to lie to you and tell you it will. There's not a hard, fast rule for this always works. It doesn't. Okay? Yeah. So step 1, let u equal something. The best place to start is the inside function. But it's not a guarantee. And I don't know if it's me picking up the marker or if it's the board. Okay? So, what is my inside on this particular integration? Okay? So I'm going to let u equal x to the 4th plus 2. Step 1. Step 2. This is what you asked for, right, Paul?
Yes, ma'am.
Okay. Step 2. Take the derivative of u. All right? So, du equals what?
4x to the 3rd.
What comes after 4x to the third?
Plus C.
C is if we're integrating. Dx. Because remember, and you may not have been in here yet, we, instead of writing du dx,
No, I was in.
alright, good. Step 3. Solve for dx. Solve for dx. What do I need to do to solve for dx?
Du divided by 4.
Me personally, I prefer to rewrite this as 1/4 du over x cubed, and I will show you why. It is completely your preference. That's my preference. Okay? Step 4. Substitute into my integral. Alright, so my integral had an x cubed, it had a cosine, and then it had an x to the 4th plus 2, so that's where my u is going. And instead of a dx, I'm using a 1/4 du over x cubed. And step 5, take the antiderivative. And just so that I can clear this board out of my way, step 6 is to replace u. What's going to hurt your feelings, honey? Oh, I'm sorry. Okay. All right, so I'm going to replace you. Now, that was pretty funny. The reason why I prefer to write the 1/4 separately is because I can actually pull this 1/4 out of the integral completely. And in my mind, it's easier that way. So I'm going to rewrite this problem now. And I'm going to put the 1/4 in front of the integration symbol. Because it's a constant multiplier. It can come out. The x cubes, what happened to the x cubes? They cancel. Cool, cool, cool. So I have the cosine of u du. So what do I take the derivative of and get a positive cosine?
I was paying more attention to the dad joke. How did you, or why could you move the 1/4?
Because it's a constant. And constant multipliers can come out to the front. Okay? So what gives me a derivative of positive cosine? Regular sign. So this is equal to 1/4 sine u plus c. Last step, replace u with x to the 4th plus 2. 1/4 sine, just take it off and set it somewhere else, x to the 4th plus 2 plus c.
That's done.
Got her? Can you see it now? Can you see it now? Can you see it now?
du is where you took the derivative of cosine.
Okay.
Oral, can you see it now? Okay. I'm about out of seconds here, so I'm going to stop and we're going to start again. Yes, sir.
Never mind. Wait, but isn't du already a... That's stressing me out.